Okay, next we will learn about another technique of matrix solution, which is using Cramer rule. Okay, this is the example of Cramer rule. Okay, this is, for example, we want to find the solution of this matrix. So how to solve this one? First of all, you need to change this in terms of matrix. So your solution will be one, two, three, 4, 5, 6, 3, 1, 2. This is your E matrix, then times with x1, x2 and x3. So then you will have 9, 24 and 4. So this is your A, this is your X, and this is your small b. So what we need to do, we need to find the determinant of this. So the determinant of 1, 2, 3, 4, 5, 6 and 3, 1, negative 2 is equal to 1, 5, 6, 1, negative 2 times negative 2, 4, 6, 3, negative 2 times plus 3, 4, 5, 3, 1. So here when you calculate, you will get your answer determinant of 3. Okay, and then how this Cramer concept works is, so here we know our determinant is equal to 3, so which is not 0, so there is a solution there. Okay, there is an unique solution. So in this concept, what you need to do, you need to find determinant of A1, A2 and A3. Okay, the step is for A1, okay, what you need to do, you need to replace your B, okay, in you need to replace your B, this is B, okay, your B in the first row, then remain the other matrix. Okay, for example, the first row will be 9, okay, it will be 9, 24 and 4. Then you remain the others. The other matrix will be 2, 3, 5, 6, 1, negative 2. Then you find the determinant of this one, you will get 12. Then, okay, so we go for A2. For A2, okay, the matrix, you put your B in second row, will be 9, 24 and 4. So you remain, the first one will be 1, 4, 3, then you have 3, 6, negative 2. Then you find the determinant, in this case you will get negative 6. And the third one, you're putting your B at the final row, sorry, final column, it's not row, column. So B 9, 24 and 6. So you remain, the others will be 1, 2, okay, then 3, 1. So you have the determinant of 9. Okay, so in order to find x1, the formula is your determinant of A1, you divide with the total determinant. So your determinant of A1 is 12, your total determinant is 3, so you will get 4. So for x2, the determinant of A2 divided by total determinant, so you will get negative 6 divided by 3 and negative 2, and x3 you have A3 divided by total, so you get 9 over 3, so you get 3. So this is how the Cramer rule works. Okay. Okay, this is another example to show the relationship between inverse method. Okay. Okay, the inverse matrix is A inverse times A equal to X as equal to A inverse equal B. So A inverse times A is equal to identity of X is A inverse B. So A inverse is A inverse B. For example, okay, show that A is 1 to this matrix is the inverse of B of this matrix. Then solve the following equation. Okay, so how to show it is, we know that A times B, it should be an identity because it said that A is an inverse of B. So we just prove it. So A times B, you will get the identity. Okay. So the second question is, hence solve the solving equation. So this is the equation of matrix in terms of matrix. So in order to solve this one, is in order to get your X is X inverse times B. So in order to find this one is X equal to X inverse this A. Okay, inverse it, put it on the right side, then you will get your X value. So we know that A inverse is equal to this one. So we just put it that B times B small, so you will get your final answer. Okay, so that's a Cramer method, Cramer rule method. Okay, Cramer rule method. Okay, so the next subtopic is another method, which is Gauss elimination method. Okay, so here is the example of the questions. Okay, linear equations. We can use another method, which is Gauss elimination method. Okay, how to use this method is, okay, first of all, this equation, three equation, we have three equation. Equation number 1, equation number 2, or equation 3 means we have 3 unknown, x1, x2, and x3. You change this one into the in term of matrix, which is 1, 2, 3, 2, negative 3, 2, and also 3, 1, negative 1. So you have the unknown of x1, x2, and x3. So then your B will be 6, 14, and negative 2. Okay, this is the main matrix. Okay, you have A, you have X, and you have small b. So in order to solve this method, so we take it based on A matrix by row. Okay, so which is you have 1, 2 and 3, you have 2, negative 3 and 2, you have 3, 1, negative 1. Then you put your b, small b here, which is 6, 14 and negative 2. So you have the matrix. So in this concept of Gauss elimination, you need to eliminate the first you need to eliminate based on row. So the main objective is you need to get this triangle, okay, to be something like this: 1, 0, 1, 0, 0, 1. Mean half of the identity. So that's our objective. So this is our objective from here to be something like here. Okay, so means, so you have a number here, for example. Okay, so means you need to eliminate based on row by row. Okay, so in this case, okay, so we have, again, I just put it again, 1, 2 and 3. Then you have 2, negative 3 and 2, you have 3, 1, negative 1. Then you have 6, 14 and negative 2. So first of all, what we need to do, we need to eliminate by row. So what we need to do is we take for example, we want to eliminate this row to become 0. You want it to become 0 here, and you want it to become 0 here. So in order to do that, you need to do, what you need to do is you need to use the I1. Okay, we start with I2. So in order to get your I2, so what you need to do is your I2 minus, okay, I2 is 2. So in order to get 0, 2 should be minus the row 1 times 2, means 2 I1. Okay, so that's in order to eliminate the first row to become 0 here, and then we want it to become 0 here. So what we need to do is for I3, so is I3 minus, because this is 3, so we should minus something around 3 here, so minus 3I1. Okay, 3I1. Okay, so when we do this one, so the metric will be, the first one will be remain the same. We don't change the first one because it's already 1 here. Okay, it's already 1 here, so no need to remain this, we should remain this one. So 1, 2 and 3, and remain it should be 6. Okay, we go for row number 2. So for row number 2 is I2, okay, we use this one, equal I2 minus I1. So your I2 here is 2. Okay, the first one, 2 minus 2 times 1, okay, it become 0 here. Then the second one, I2 is negative 3. Okay, so maybe I help you. Okay, what we can do is, for example, the first one is 2. 2 minus 2 times 1 become 0. Then the second one is negative 3. Okay, minus 2 times 2, so it become negative 7. Then the third one is 2, okay, minus 2 times 3, so it become 2 minus 6 become negative 4. And the last one, 14, okay, minus 2 times 6, so it become 14 minus 12, it become 2. Okay, so automatically you can put it here, become 0, negative 7, negative 4 and 2. Okay, so done for this one. So we go for the second one, the row. Okay, so now the third row for the first one, the first column will be 3, okay, minus 3 times the first row 1 to become 0. Okay, then you have 1, okay, this is 1, the second row, okay, we are here, so minus 3 times the row number 1 is 2, so it become 1 minus 6, so it become negative 5. Then you have negative 1 minus 3 times 3, so it become negative 10. Then for the last one, negative 2 minus 3 times 6, so you will get negative 20. So just put it here, so it become 0, negative 5, negative 10 and negative 20. Okay, so now we already eliminated the first 0 and the second 0, so this one done, this one done. Okay, next we want to eliminate this one to become 0. So what we need to do is, okay, for this one, so you will get I3, okay, should be, we take 7 times I3 minus 5 times I2. So what you do is, we will have 1, 2 and 3, we have 6, we have 0, negative 7, negative 4 and 2, and the last one, okay, will be, okay, we can do it here. For example, the first one becomes 0, 7 times 0 minus 5 times 0, so become 0. Then you have negative 5 times 7 minus 5 times negative 7, so this one also will become negative 35 plus 35 becomes 0. Then you have negative 10 times 7 minus 5 times negative 4, so what you have is negative 70 minus plus 20 become negative 50. Then the last one, we have negative 20 times 7 minus 5 times 6, so negative 140 minus 30, negative 140 minus 30, yeah, no, this one should be times, not times 6, so it should be times 2. Okay, so negative 120 minus 10, 140 minus 10 will be 100, negative 150. So just put it here, it becomes 0 here, it becomes 0 here, so it becomes negative 50, it becomes negative 150. So this is the second step. Okay, so now what we can see here, okay, what we can see here, this one already 0, this one already 0, and this one 0. So the next is, we must make sure it become 1, 1 and 1. So this is quite easy. So what we need to do is, we need to make sure everything become as half of the identity will be 1, 2, 3, 6. So it becomes 0. So this one will become, you just negative 7, negative 4 and 2. This one will become 0, 0, negative 5, 50, negative 150. So this is the symmetric. So what we need to do is, we need to change to I2 become negative 1 over 7 divided by I2. Then I3 will be negative 150, sorry, negative 1, negative 150 means divided by negative 150, so will be I3. So will be, this one will be 1, 2 and 3, 6. The second one is 0, so negative 7 divided by negative 1 over 7, so it become 1. So negative 4 divided by negative 1 over 7 will be 4 over 7. Then we will get negative 2 over 7. Okay, then the third row will be 0, 0 and 1, and the last one will be positive 3. Okay, so this is your matrix. Okay, from here back to x, y, z, we know that this one should be a x1, x2 and x3. So what we can say that automatically we know that x3 is equal to 3. Okay, this one should be equal to 3. So from here you can solve the equation for row number 1. Okay, so this is for row number 3. For row number 2 is x1 times 0, we are taking this row, okay, plus x2 times 1 plus x3 times 4 over 7, so will be negative 2 over 7. So we know x3 is already 3, so what we get here is x2 plus 4 over 7 times 3 is negative 2 over 7. So here you will get x2 is equal to negative 2. Okay, so when you get x2 is negative 2, you can do for x1. So the row number 1, this one is from I3, this one is from I2. Then you can do for I1 will be x1 plus 2x2 plus 3x3 will be equal to 6. So when you put it everything, you will get x1 plus 2, which is your x2 is negative 2, plus 3, your x3 is 3, equal to 6. So you get x1 is equal to 1. Okay, so hence your solution x is equal to x1, x2 and x3 is equal to 1, negative 2 and 3. So this is how Gauss elimination works. So what you need to do, the main objective is you need to eliminate this into this form. So you need to eliminate one by one row, so then you can get in terms of this form, then you can start to answer the questions. Okay, okay, next is about eigenvalue problem. Okay,